Hello, and welcome to Boot Camp, Unit 8B, Exponent and Root Laws. We are going to be looking at actually finally getting to exponents and figuring out what those are, and looking at square roots. And from there, we can look at what are called cubic roots and further on and on. When we talk about exponent laws, you see the three main laws in front of you here. We have, when you have two things with the same base being multiplied, you keep the base and you add exponents. Looking on the right, if we want to find x squared times x cubed, well, how many x's do we have? X squared is x times x, and x cubed is x times x times x. You'll see that we have 5 x's in total. So that is x to the 5th, otherwise known as 2 plus 3. If we want to find two things that are being divided with the same base, we have to actually write them out and subtract the exponents. Keep the base, subtract the exponents. If we have, for example, x cubed over x squared, on top we have x times x times x. On bottom, we have just x times x. With fractions, if you see something that's being multiplied that's the same, they can cancel out. And we're left with just 1x on the top, or x to the 1st. Otherwise known as 3 minus 2 as the exponent. The last one we have is a power to a power. When you have a power to a power, you keep the base and you multiply exponents. If we wanted x cubed squared, well, think about what that is. We have x cubed times x cubed. So we can just simply add the exponents there. 3 plus 3 is 6. But what if we have something like x squared to the 17th? You don't want to write out x squared 17 times. You could, but we could just add up 17 2's. 2 plus 2 plus 2. That's just multiplication. 2 times 17 is 34 in this case. Square roots then go the other way around. If exponents are looking at repeated addition or multiplication, then square roots are doing the opposite. Well, what you see here is the square root of 16 is 4. What does that mean? Square roots, you'll see as we go on to cube roots that there's a little number. It's called the index of the radical. For square roots, that is 2. So what we can say is that 4 squared, or 4 times 4, is 16. So just phrasing it in a slightly different way, the square root of 16 is 4. Let's grab a bit of a bigger one. What you see here are the 9 perfect squares between 1 and 100, exclusive. So if we want the square root of 64, the question to ask is, what times itself is 64? In this case, 8. We're going to be playing with these square roots a lot coming up. Cube roots are the same idea, but instead of multiplying it one time, or I should say rather, it's a number times itself, we're doing that 3 times. So as you see here, the cube root of 27 is 3. Why is that? Because 3 times 3 times 3 is 27. 3 times 3 is 9, times 3 is 27. And we've multiplied 3 times. Take, for example, the cube root of 64. That is 4 times 4 times 4. You'll see that, yes, these are often represented by cubes. More on that when we get to geometry. And what you also see in front of you here is that the cube roots grow much faster than the squares do. Because we're multiplying an extra time, things get bigger really fast. And so what you see here, we had 9 until we got to 100. Here we have 10 and we're at 1,000. That extra multiplication makes it grow so much faster, so fast. We can extend this to fourth roots and fifth roots and so on, though those are often very situational, and when your professor needs you to use them, you'll know. That was Unit 8B, an introduction to exponent and root laws.